Hello to all my Chem 9 students. Miss Benson here. I'm recording a podcast for you guys standing in my room with no one in here talking to myself, but hopefully this will make sense to you, and whatever you don't understand, Mr. Fleck will be able to help you out, and then we will also discuss it on Friday in class. So I'd like you to be in your notebook, and let's turn to page 39. And our essential question for the day is, how do atoms gain stability? We talked a little bit about this yesterday in class. Okay, so how do they gain stability? Atoms are stable when they have that full outer energy level that we talked about yesterday, and they become stable by gaining or losing electrons. There has to be something near them that wants that, and it's going to have that attraction. So let's write a couple of these points down. Okay, so atoms are stable when they have a filled outer energy level, and they do this by gaining or losing electrons. And what they are trying to do, I think we talked about this yesterday, is to become stable by gaining or losing electrons. They want to have that noble gas configuration. They try to attain that. Okay, so they try to attain that noble gas configuration. So if we're looking at our periodic chart, I hope that you're thinking to yourself like, okay, I know that those are my noble gases. I'm looking at this family right here. I remember that families go up and down. And all of the elements on the periodic chart, they want to look like this family and have the stability of the noble gases. So this is how they become, or this is how they do that, and you are writing with something that is probably gaining or losing electrons right in front of you. So they become ions, so I-O-N. Okay, so what's an ion? It's an atom that has gained or lost an electron. So it's an atom that has gained or lost an electron, and when that happens, we have to remember that electrons are negative. And because electrons are negative, then the element is going to become charged. So there's two ways that we classify ions, and the first one is called a cation. So if it's a cation, it means that it has lost electrons, okay? And the ones that lose electrons very easily are metals. So I think we're hopefully looking at our periodic chart, and we are thinking that, well, we have metals on this side of the chart, and they are the ones that want to lose their electrons very easily to become like the noble gases. And remember our home run, what they're trying to do is they are trying to look like a noble gas in terms of stability. So I would like you guys to go ahead and let's look at magnesium. So that'll be our example here. So if we look at magnesium, right now it will have 12 protons, sorry that looks weird, 12 neutrons, and 12 electrons. And if I put it into my Bohr diagram, we know in the middle that I would have my 12 protons, I would have my 12 neutrons, that makes my nucleus. Then go ahead and draw your 3 energy levels. Probably good if you guys start using some other colors in your notebook so you can see the electrons. Remember that we are going to put 12 electrons into our diagram. So we know right now that 2 electrons go in the first shell. We have 8 in the second. I know some of you might be using numbers, that's fine. So then I have 2 plus 8 is 10. I have 2 more electrons in that outer shell. So what happens with this ion, because metals want to lose their electrons. So the outer electrons are the ones that are easy to lose. So magnesium can lose 2 electrons. Now I hope you're looking at the periodic chart and saying, well, magnesium's right here. It's in the second family. It has 2 electrons that it can lose. If it loses those 2 electrons, you can see the atomic number 12 there. I kind of covered that up. But the atomic number 12, if it loses 2, it goes backwards to the noble gases, and now it looks like neon. And neon is a noble gas, and that's what it's striving to be like. So it does that by losing 2 electrons. So we can see before magnesium has 12 protons, 12 neutrons, 12 electrons. After, it's still going to have 12 protons, 12 neutrons, but now it only has 10 electrons. If I look at the charge there, I have an excess charge of plus 2 charge from losing the electrons, and I have extra proton charge. So the charge on magnesium now is Mg plus 2. Now I know it seems weird because it's giving something up, but we have to remember electrons are negative, and that's why it has a plus 2 charge. Okay, and then it has the noble gas configuration of neon like we just said. So we're just going to kind of continue with our notes. I know normally we do some sort of output activity, but we're just going to continue because we have one more diagram I want you to show. So please go to page 38. So flip your notebook over. And we said that one form of ion was a cation, and the second form is called an anion. Okay, anions, they are going to gain electrons, and nonmetals are the ones that want to gain electrons. Okay, so they want to gain electrons to gain their stability, and nonmetals easily do that. Well, let's look at where they are. If I look on my periodic chart, over here are my nonmetals, right? And if I look at sulfur, it just needs to gain 1, 2 electrons to look like argon. Iodine, it's right here, it just needs to gain like 1 to look like xenon. So you can see the ones on this side of the chart, all they need to do is gain some electrons to get over to the noble gases. So let's draw oxygen. So let's look at oxygen. You should recognize that oxygen, first let's write that down. Oxygen has 8 protons, 8 neutrons, and 8 electrons. Now I know it looks pretty stable like that because it doesn't have a charge, but it really wants to gain more stability like the noble gases. So if I draw my Bohr diagram again, I have 8 protons, I have 8 neutrons in my nucleus. This time we only need 2 energy levels because of only 8 electrons. Let's put our electrons in. So we have 2 in the first shell. 1, 2, 3, 4, 5, 6, 7, 8. So I got 2 in the first, 2, 4, 6 in the outside shell. So how is it going to gain stability? Is oxygen is right here. Well, if it wants to get to neon, it needs to gain 1, 2 electrons. Does it have room to do that? I think so, because we know that we can get 8 on this shell out here. So if I bring in 2 more electrons, then it is satisfied and has 8 in its outer shell. So as an ion, which means it's now charged, it's now going to be an ion, it's still going to have 8 protons, 8 neutrons. That's not going to change. But now instead of 8 electrons, it has 10 electrons. And when I look at the charges, I have 8 pluses, I have 10 negatives. That means I have a -2 charge. So we write that as a -2 charge, and that means that oxygen has -2. And that's how it's going to gain its noble gas configuration. Okay, so I hope that was slow enough and you can make some sense of that. And we are done with notes now. What I'd like you guys to do is take out your homework packet and go to the second sheet. And the front side of the second sheet has a whole bunch of questions, and you should be able to answer that. It says happy atoms on the top. Please go to the back side of that. I want to show you how to complete one of these. We do have an example here, and it looks like they didn't draw the dots here, so we'll just follow through with the magnesium. Magnesium, symbol Mg. We have 2 valence electrons, so the electron dot diagram should have 2 dots here, like what we did in homework 1. When it loses those 2 electrons, it wants to become neon. How is it going to lose? 2. There's its charge and the ion name. So let's go through the next one. Let's look at chlorine. All right, you should see that chlorine has a symbol of Cl. And let's see, let me get to my periodic chart here. If I look at Cl, let's erase some of this junk I got going on over here. If I look at chlorine, I think you can see that it is in family 7 right here. Remember, we take the 1 off of here, so it's family 7. So it has 7 valence electrons. It wants to look like argon because it can go from 17 to 18 pretty easily by gaining 1 electron. So let's write that all out. Sorry, I keep going the wrong way. All right, so we have chlorine. It has 7 valence electrons. Its diagram will be Cl. Draw the 7 electrons. 1, 2, 3, 4, 5, 6, 7. I keep doing that in the wrong order, but we got 7 there, kind of. All right, we got 7. What gas does it want to be like? It wants to be like argon. How is it going to do that? Is going to gain 1 electron. And if it gains 1, electrons are negative. So that means it's gaining a negative. How much? -1. And the ion name, oh, I forgot to mention this on my last slide, becomes chloride. So if you can see that the metals, magnesiumide, I don't think you've ever heard of that. Magnesium, when they lose electrons, they keep their name. It's just plain old magnesium. It's just a silly rule that when chlorine bonds, it's not magnesium chlorine, it's magnesium chloride. They will all have IDE endings. Okay, so let's try one more with the metal. I know what Li is. It's lithium. And it's in the first family, so it has 1 valence electron. I think you have this one as an example in your notes. You have it to there, Li with 1 dot. Okay, let's look at our periodic chart. Here's lithium way over here. So let me erase some of this so we can see what we're doing. So we have lithium right here. Well, it has atomic number 3. So go over to the noble gases. I have atomic number 2, atomic number 10. Well, which one is closer to is 2. So metals want to lose electrons. So if it loses one electron, it's going to look like helium. That's what it's closest to. So it wants to be like noble gas helium. It needs to lose one electron. And when it loses, you have to remember, you have to think opposite. It means it has a +1 charge. And because it is a metal, it does not change its name, lithium. Okay, well, I hope you guys can make sense of this. And Mr. Fleck will be here to help you out. Ms. Sievert also has an answer key, so make sure that you're getting your questions answered. Please be role model students, and I will see you on Friday. Have yourself a wonderful day. And remember, think like a proton, always positive. I hope you're smiling.